Hello, it's me, Derek, your local CPSC 103 TA, and I'm going to be going over the hardest final exam question I've seen over my years of TAing. Yes, I've been TAing for 2 years, 5 terms in total, and I don't expect to see a problem this difficult this term, but here it is. Okay, so this is a line chart problem, and we are going to read this problem together. Feel free to pause if I'm going too fast. So consider a fictional social media company named Owly. In Owly, users are able to post chirps, which are short text-only messages, and other users are able to like and rechirp other users' chirps. So rechirping is kind of like retweeting, and thinking about this company is really like Twitter. And we're given a bunch of data definitions, and we want to design a function that takes in a list of chirp engagements and a chirp ID and displays a line chart of the total chirp engagements, which is the number of rechirps plus number of likes over the days since the chirp was posted for the chirp ID. Note, for a given chirp, there can be multiple chirp engagements for a day. So this is important. So for example, we want to find the number of chirps or number of likes for a given day. We must sum up all the likes inside our chirp engagements of that day. So what this means is that we have this compound. So chirp engagement contains a chirp, which is another compound. And inside chirp engagement, there is days after chirp, number of rechirps, number of likes. And I guess every single chirp engagement for a given day, there could be 2 of them, and we want to combine it together if that's the case. Like, let's say there's inside a list for a given chirp, there is a chirp engagement for day 1, and then there's another chirp engagement in that list for day 1 also. And if we want to find the total number of likes for day 1, we have to add up both of those chirp engagements. So we should read over the data definitions. They give us 2 compounds and a list of chirp engagements. And here's the interesting thing about this problem. We don't see this often in this course, but they have given us like a function and its helper functions, and they're fully completed. What we want to do is read the purpose and figure out what to expect when we enter input into the function and what the output would be. Okay, so let's read the purpose. So what this helper function does, which is sort and combine duplicates. So it combines engagement numbers for a duplicate days in LOCE and sorts by the days after chirp and returns results. And we must assume that all elements of LOCE contains the same chirp. Okay, so to figure out better what it does, we want to look at the test that was provided here. So let's see, let's find the test. Okay. So empty list outputs empty list. That's not really helpful for us. Okay, so looks like when we input CE2 and CE1 inside a list, CE1, CE2. Okay, so what this example is saying is that it's going to sort them, and I guess this example is probably more useful. It shows that if you put in a list of chirp engagements that of like 2 of them is like day 5, it would output just a single chirp engagement of day 5, and it'll add up all the likes and all the rechirps together into one. So yeah, that's a good way to go over it. Okay. So to start this problem, we want to first figure out what the input and output of the function that we're designing should be. So inside the problem statement, it says design a function that takes in a list of chirp engagements and a chirp ID. So let's do that. Okay. Give it a name. I'll call it plot chirp engagement timeline. So take in a list of chirp engagements. And it says it's going to take in a chirp ID. Which is a string. And what does it output? It wants to display a line chart. So when we're displaying a line chart, we return none. And then we can start by writing the purpose. Displays a line chart which shows the daily chirp engagement, which is likes plus rechirps for a given chirp ID in and list of chirp engagement. So what it really wants is it wants like wants the y-axis should have chirp engagements, and the x-axis should have days after the chirp. Yeah, because chirp engagements, we have the chirp and we have days after chirp. Okay, then the next step in the how to design function rules for this course is to write a stub. And in this case, it's none because we're outputting a graph. And we've got to start writing the test. Okay, so for this test, we can pass in a list of chirp engagements, and the output here would be none. We want to run this test to make sure our test is well formed. Okay, so we get an error here, which is a good thing that we ran the test. So we actually need to put in two arguments here. So we've got to put in the list of chirp engagements, and we're going to put in the chirp ID. So I guess, for example, I could take chirp ID from one of the defined chirps up above, click run, and it should work fine. Okay. Alright, so now we gotta go on to the next part, which is coding the body. From here we want to use a template. So in this function we're plotting a graph, and so therefore the template will be from visualization. What's useful is to go onto the exam sheet, and we can copy paste some visualization function signatures. Okay, this is pretty useful in helping guide us how to do this problem. So when we're doing a plot, in the end, what we actually want is we want to have a list of floats and another list of floats. The first list of floats represents the x values, and the second point represents the y values. Both lists should be the same length, and the first value of the x data will correspond with the first value of the y data. It's kind of like you take two values and it makes a point on the graph, and it goes in order that way. Now the challenging part really is to figure out how to get the x and the y values. So looking at the problem, we were given a list of chirp engagements and we're given a chirp ID. and we really only care about the chirp engagements of the given ID. So what we want to first do is we want to filter the list by the chirp ID. So we want to only take the chirp engagements of the given chirp ID. So I'll call it, so let's do that first. So what we want to do is actually use a helper function for this. So maybe call only maybe call it engage means matching ID. And then, so we gotta write a function that maybe we call it filter by ID. And what we want to pass in for this function is we want to pass in the list that we're filtering and the chirp ID, so we know what to filter from. Okay, so after we filter that, we also have to take note that for a given chirp, there could be multiple chirp engagements for a single day. And we want to combine like multiple days into a single chirp engagement. That's pretty complicated to do, but it's a good thing that they gave us a helper function here that was already designed for us. And one of the preconditions for this sort and combine duplicates is saying that assume all elements from LOC contains the same chirp. So that's the reason why we had to filter out the list by the chirp ID first. And then like after we filter it out, we have like a list of only like a single chirp ID. We are able to call this sort and combine duplicates. And we can pass in the list that only contains a single ID. And then I guess I'll call it sorted combine. Okay, so we have the sorted and combined engagements from this. And after we do that, we do want to have a function that will end up getting our final x values. Maybe we could call it get days. And we'll pass in that list that was already sorted and combined. And we also want to get the y data. And I guess this would be getting the total engagements. And we want to pass in this sorted and combined engagements. All right. Actually, we should start writing the helper functions. So let's start by writing this filter by ID function. Okay, so what we said that it takes in is that it takes in a list of chirp engagement and takes in a chirp ID. So we can copy and paste from here because these input types are the same. And what this thing does is that we want to, for a given list of chirp engagements, we want to filter it out so it outputs a list of only the chirp engagements with the given chirp ID. So therefore, the output will be a list of chirp engagement. Returns a list of chirp engagements. Alright, so now we're done running the purpose. Now we'll write a stub. A good stub to do with a list is an empty list, because you can put any value in a stub as long as it matches the type of the output. And from there we can write, for the purpose of sake of time, I will write a single test. When you do this problem on your own, you can write multiple tests. So A good trick to use to do when you write tests is to use the provided data. In this case, they provided a list of chirp engagements, and we can just copy paste that and send it in there, and it also takes in a chirp ID. So let's see, this LCE2 has 0, 1, 2, 3, 4, 5, 6. So every single one of them is C1 except this one. So we can, if we take this, the chirp ID from C2, passed in here, what we should output is just this chirp engagement, because all of the rest of them has this chirp ID, and we want to filter it out, so the list only contains it with this chirp ID. Alright. Okay, that's good. Our test is failing, but it is running without errors. Okay, now we can comment up the stub. Okay, so in this case, now we want to figure out what template to use. A good way to look at it is the inputs. So in this case, the input is a list of chirp engagements and it has additional parameters, so therefore the template is from this chirp engagement with additional parameter. Alright, and then we want to go to the exam sheet, and then we want to copy paste the template. Actually, no, we don't have to go to the exam sheet in this case. We already have a template up here because the thing was already defined. Okay. Alright, so now we can start coding this function. For the accumulator, generally the accumulator is the same type as the output. And I guess in this case it would be, you can make it an empty list. It's not always the case where the accumulator is the same as the output, but in most cases it is. So what we logically want to do is we want to go through the entire list, and as we're going through the list, we want to append the chirp engagements that have the same chirp ID. So we actually do need a helper function for this, because chirp engagement has a field chirp, and inside chirp there is a chirp ID. So according to the helper rules, we're going into a field inside a compound, and we're doing more than just accessing it, so therefore we do need a helper function for that because of the reference rule. Okay, so what we want to do is we want to is chirp engagement matching ID. Okay, we want to see if the current one is matching with chirp ID, and if it is, then we'll do the append. And in the end, we will return the accumulator. Alright, so now we've got to write this helper function. Okay, is chirp engagement matching ID? So judging from the call to this helper function, CE is of type chirp engagement, so therefore the first input has to be chirp engagement. I could put his name is C. And the second input is chirp ID, which is a string. And what it wants to output, the way it's being used is inside this if, so therefore we want to return a bool. and for the purpose. Okay, so returns true if chirp. If C has a chirp with the given chirp ID. Okay, so now we gotta write a stub. Here's the boolean. We can only put 2 values for the stub, either true or false. Choose true, and we'll write a test. As usual, we will only be writing a single test. Yeah, so you will have to write more than one test when you actually write this problem on the exam. Okay, should be true. Alright, good. The test is well formed. Now we can comment this thing out. And then now the template here, we based off of the inputs. So we look and see its chirp engagement. So we'll scroll up to chirp engagement. Then we can copy this template. Okay. And then we want to return true if C has a chirp with the given chirp ID. And then from here, we want to actually access this chirp. So as you can see from the template, this is another one of these reference rules. So inside chirp engagement, we have a field name chirp, and chirp is a non-primitive type. So that means it's like compound or optional or a list, or those are examples of non-primitive type, or even enum. So that means that according to the course rule, we have to write a helper function for that. And it also shows up on the template, because we want to access this chirp field. Yeah, so we want to see if the chirp inside C has the same chirp ID. So for to do that, we got to pass in a chirp, and we got to pass in the chirp ID. Okay, so the type inputted will be chirp for sure, and chirp ID is a string. And what it will output, so the way we're calling this function is inside the return of this is chirp engage matching ID, which output type is a boolean. So therefore, the output type here also must be a boolean. Return true if C has the same ID as chirp ID. Okay. So from here we can write a stub again. Yeah, stub, and we'll write a single test. Is chirp matching ID and passing a single chirp. Okay, I'll pass in C2. And C2's chirp ID. So therefore, we should also expect this to be true. Okay, problem here, C is not defined. Okay, oh, that's because I changed the parameter name for the function above, but alright, okay, good. So 3 out of 4 passed. So that means the previous test that we wrote for the previous function I ended up passing, and this is the one that's failing because it's 954. Okay, so yeah, it actually turns out the one in line 54 is failing. So, which is, oh yeah, that's because this function is not done. That's why it's failing. Okay, so now we will comment up the stub and continue coding the template. And the template here we based off of chirp because chirp is the input. So we can go up to chirp and we can copy the template here. Also got to write the template statement for the previous function. Okay, so from here we can just access the chirp ID, and since chirp ID is a primitive type, it's a boolean, or no, it's not a boolean, it's a string. So string is a primitive type. We don't need to do a reference rule, we can just do an equal sign to chirp ID. And then let's run it. For whatever reason, okay, so it seems like we forgot these square brackets in order to make it a list, because previously without the square brackets, this CE6 is just a single chirp engagement, and in the filter ID we want to return a list of it. And it also seems like we're missing this C dot chirp ID. Okay, so now all 4 tests are passing. Alright, good. Okay, so from here it seems like we got the engagements with the matching ID, and then we call this sort and combine duplicates, which is all done for us. And then now we have this sorted and combined duplicates. Next step is we want to code this getDays function. Okay, so from the way it's used, it just takes in a list of chirp engagements, and it outputs the days. So the days here should be a list of days after chirp engagement. I guess it'll be a list of int. Yeah, okay. Int. That's a list of days after chirp from LOCE. As usual, stub, we just want to do a empty list. And we can write a test. So good test here is to, I guess we could just use LCE1, I guess. And its output will be a list of int that corresponds to the days of LCE1, days after chirp, so it'll be 0, 1, 2, 3, 4, 5. Okay. 5. Okay. Run the test. One of them failed, that's good. Now we will get the body, which is template is from list of chirp engagements. Okay, and let's see, the accumulator will be a list. Output type is a list int. I'll comment the stub. And let's see, we want to go through this list of chirp engagements and we want to just append the days after the chirp. And in this case, we don't need a helper function for this because we're just going to access an element inside a compound field, accessing a field inside a compound, which is the days after. We're just accessing it and appending it. We're not doing anything like comparing or doing an addition or something like that. So we don't need a helper function according to the course rule. Okay, all 5 tests passed. Good, and then after this, we want to get the total engagements. Right, we're going to code this function. And what this function does is that the total engagement, as described earlier, is the number of rechirps plus the number of likes. So we're going to go through this list of chirp engagements and we're going to just get a list of integers that is the likes plus rechirps. Write a single test. Let's pass in this LOCE1. Okay, so from there we know that the first one will be the first element added, the first chirp engagement added together, second. Okay, so it's probably easier to just move this thing down. Okay, so the first one will be outputted will be these two values added together because this is number of likes and number of rechirps. Or it might be the other way around. Rechirps and then likes, okay. 5 rechirps, 123 likes. And we want to add them together, and we're going to do that for every single element inside this list. Okay. Okay, test and file form. So now the template is also from list of chirp engagement because the input is chirp engagement. Copy pasting that. Okay. So now from here we want to add them together. So from here we should have another helper function. Yeah. Add chirp. And after we add all of the chirp engagements, we will then return the accumulator. And from here, we take in a single chirp engagement, and we want to output an integer because of the way it's being used. acc.append. Oh, whoops. Oh, I didn't even copy the full template. Yeah. Okay. So from the previous function, the accumulator is a list of integers, and we're going through this list of chirp engagements, and as we're going through each element, we're appending the total number of engagements for each chirp engagement total. Yeah. So I believe it's pretty good to specify that what total engagements is in the previous function as well. Stub has to be the same type as the output. In this case, would be 0. Go write a single test here, and for that we can pass in C2. What is C2? No, we want to pass in a chirp engagement. We cannot pass in CA2. Let's pass in CE1. And we output from CE1, it should be 107. Alright. 2 of the has failed. That's good, because it's this one failing and this one failing. Okay, and now the template is based off of chirp engagements, which is the input. Okay, we only care about the rechirps and likes. In this case, we just add them together. CE dot num rechirp CE dot num likes. Okay, all 7 tests pass. Perfect. Okay, so now we'll go back to the main function, and when we're calling the function, do not specify the type or you'll get an error. So this is why I'm erasing this, even though it was part of the exam sheet. Okay, and no plot shows up because we didn't call it. Should call it with. And OE2 has all of these. It's called without this trip ID. Okay. Alright, so it seems like the reason why it wasn't working was because this return none inside the main function that we were writing was not commented out. And also we wrote a function named getDays. Originally it was named getDays, and that was already defined above. So I renamed our getDays to getDays2. We should not name any 2 functions the same name, or that will cause problems. But yeah, that is it for the hardest exam problem I've seen in my 5 terms of TAing CPSC 103. Thank you for watching.